Hi, and welcome to the second episode of It's Not Obvious Java Edition Mac OS X. Today I'm going to be talking about statements, expressions, and comments. And in this episode, the prerequisite to this episode actually is for you to have already watched the introduction to BlueJ video. But if you haven't, I'm still going to do a brief recap of setting up a basic Hello World project, compiling and running the code. Then we're going to go right into basic statements, print and print line, and then expressions, values, basics of operators, and a really brief introduction to variables, which really just have to do with integers as well as strings. And we'll wrap it up by talking about commenting, what it is, how you do it, and so on. This episode is primarily for my CSS 142 students at the University of Washington. That being said, if you are new to Java programming, you will probably find this useful in terms of getting started to understand the basic concepts of statements and expressions. All right, so if it matters who I am, I'm Hansel. I'm currently a part-time faculty at the University of Washington. I am also currently a software manager during the day at Amazon, specifically with AWS Kumo. If you want to know more about what I've done, please check me out at LinkedIn and feel free to send a connect request there. Before we begin, I want to go over whether what I'm talking to you today is programming. It's sort of. It's really only the very beginning of the very basic tools that you're going to use for Java programming. Main method, expressions, statements, as well as comments. If we think about the PET model, which is my acronym for problem solving, engineering, tools, and terminology, we're still talking about just the tools and terminology. We're not going over problem solving or engineering just yet. Okay, so let's go straight into our Hello World example. First, we need to create a project, and then we need to create a new class. And remember that BlueJ automatically provides default code. We don't need a lot of the code for now. We're going to be adding a main method, in other words, public static void main, string array args, and we're also going to experiment with print statements in the main method with print line as well as print. You can probably copy or type exactly what I have over here, but I will also demonstrate what that means, what that looks like. All right, so let's go to BlueJ. And I will also demonstrate like I did last time. Right now, I don't have anything in my desktop. We can go to BlueJ project, new project, and we'll say Hello World again. And the moment we save it, keep in mind that you need to remember where the location is because that's where your files are going to be located. Right now, I have set it to desktop. And it creates this folder, Hello World again, with package BlueJ, readme.txt, and we are going to create a new class. This is one of the ways that we can create a new class. We'll say again, Hello World, and say class. It automatically creates this hello world.java file. All right, so now let's go in here. Remember again that BlueJ creates all of these things by default. This is actually an example of multi-line code. We will be talking about that later in this episode. And this is another example of single line code with just the 2// and another multi-line code and a bunch of other stuff. This here, private int x, is an example of a variable. Specifically, it's an instance variable. For now, don't worry about what that is. We'll talk about variables a little bit today and a lot more in the future. Okay, like I said, we don't need a lot of this just yet. So we're just going to delete, and then we get to type in public static void main, open parentheses, string, open close square bracket, which is another word for array, args, and that's it. Okay, great. So that's our first step, adding a main method, public static void main, string array args. Then we want to provide the print statements in the main method. One is println, which is a print line, and the other is print. So let's try both of these out. System out println, hello there. And then let's do system out print. Thanks for watching my video. Okay. Now the question is it obvious what the difference is between these two lines? Well, let's give it a try. So first, we're going to right-click on Hello World on this page, which is the project view page. We're going to compile. Then we're going to right-click again and select void main string array args, which is how we run the code. Great. Then we click OK, and we see this. Hello there, thanks for watching my video. Now, again, my question to you is there any obvious difference between print line versus print? Chances are at this point, there's nothing too obvious about it just yet. But let's say if I were to change the order of this system out print and system out print line, thanks for watching my video, hello there. Okay, so again, we'll compile and we will run this code. And now you can see, thanks for watching my video, exclamation, hello there. So if it's not obvious to you yet by now, print simply prints to the screen, whereas print line prints whatever is in this parentheses to the screen, and then it creates a new line. Now, if this is what you want to do, that's fine, perfectly legit. You can totally do something like this. If not, if you want to have thanks for watching my video and hello there in separate lines, then you can simply do print ln thanks for watching my video. Cool. Let's compile, run this again, and confirm that it works the way we expect it to. Yes, it does. Awesome, great. Another thing that might not be obvious to you is that system out print line in itself can also be created in order to create just an extra line. So let's see what happens if we do system out print line, open close parentheses, semicolon to end the statement, and then execute this. Now you see here, thanks for watching my video, which is one print statement. Then we have another print line with nothing. It just creates an empty line. And then hello there. All right, great. So that's the beginning of being able to print statements into the program from the main method. All right, so let's go to making a statement. There are a couple of different ways to make a statement in Java. There's what's called single line statements, which ends with a semicolon, and block statements, which typically begin or end with open or close curly brackets. Now, the question is going to be, what happens if you don't include the semicolon, or what happens if you miss an open or close curly bracket? We'll explore that in a moment. But the good habit is once you open a bracket, immediately close it and then enter what's needed in between the brackets. So here we have system out print line, thanks for watching my video, semicolon. If you miss the semicolon, you get the error message, semicolon expected. Same thing, you have actually created block statements. If you've been following me all this time, you have a block statement for public class hello world, this open close curly brackets. And when you create the main method, you also have the open and close curly bracket. Now, if you're missing one of them, let's say if you're missing the closing curly bracket for this main method, you can see here that the boxes, the color of the boxes changes a little bit. Now, basically what this is saying is that the program, in this case BlueJ, the IDE that is BlueJ, is thinking that public static void main, the closing bracket is this one, which means that for some reason it thinks that there is no ending to the public class hello world bracket. Okay, so which means that there's an opening bracket here, and despite the fact that the closing bracket is in the same indentation as the opening bracket, it doesn't work that way for BlueJ. It thinks that this closing bracket matches to this opening bracket. And to fix it, of course, we simply add another bracket, and you'll notice also that the error says reach end of file while parsing. It basically just means that, hey, I'm expecting that there's going to be more, but then I reach the end of file, there's nothing there, something is wrong. That's basically what BlueJ is telling you here. Now, you'll also notice that what happens here is that you end up with this really weird kind of indentation, because this is supposed to be in the same indentation as this one, but it's not. So we can also go to Tools. Actually, we can go to Edit, Auto Layout, click it, and BlueJ as an IDE, as an integrated development environment, automatically creates this indentation or fixes it for you. Awesome. Pretty magical, pretty nice. All right, so those are the basic statements, the basic ways that you can create a statement. Having a semicolon, having open and close brackets if you have block statements. So let's move on to expressions. An expression is part of a statement that becomes a value. So you want to think in terms of mathematical expressions. So for example, what is 2 plus 2? Mathematical operators as part of an expression works mostly the way you expect it to, and in a moment I will show you what this link is like and what's there. Programming expressions, by the way, are not actually limited to mathematical expressions. There's a lot more than mathematical expressions. Now, the computer processes or evaluates the expressions first before executing the rest of the statement. In general, the computer actually executes code left to right, top to bottom, but even this general statement about how computer executes code changes very quickly as we learn more, as we do more. Okay, so let's think about expressions from the perspective of operators. Now, this is the page from oracle.com, Java documentation. This is the official documentation. I cannot emphasize that enough. This is the official documentation from the people who created Java. If you're looking for quote unquote the word of God, this is basically it in terms of Java, because these are the people who created it. Now, you'll notice also that this has to do with Java tutorials where they go over a lot of different stuff. And one of the things that they are demonstrating here is the use of operators. There are some assumptions that they're making when you go to a page like this. For example, here it says, now that you've learned how to declare and initialize variables. Now, if you've been following my video, well, you haven't actually learned how to declare and initialize variables. That's the next video after this one. But for now, it gives us an understanding of all the various types of operators that we can use. Now, it says operators, postfix, precedence, unary, etc. A lot of these things are not going to make a lot of sense to you just yet. Not going to worry about it. I'm going to simply demonstrate to you what that means. Right, so let's go back to the code and demonstrate some operators. Let's start with a simple statement that says 2 plus 2. Whoops, 2 plus 1. Okay, system out println 2 plus 2. Compile, run it, and we see that it prints out 4. All right, well, let's make something a lot more complex. Let's say 1239 times 193. Compile, run this, and we get some number which I'm going to assume is correct because I cannot do math that fast in my head. All right, so there's a bunch of other stuff, of course, that we can do, including division, compile, run this, and we can also do some complex mathematical statement. But wait a minute, what happened here? I'm pretty sure 1239 does not go into 193 6 times exactly. So let's double check. System out println 193 times 6, and we'll see what that actually is. And if you do that, 193 times 6 is actually 1158. It's not 1239. It's not 1239. Now, why is it doing that? Now let me show you yet another thing. Let's say we do 1239 divided by 193.0, compile, and we run this, and now we get the full thing where 1239 divided by 193.0 is actually this decimal number 6.419, etc., etc. Why does it do that? It does that because Java has a concept of type, of data type. And 1239 and 193, the way we had it before without the period, is treated as a whole number, and as a result, it does what is called an integer division, where it simply gets rid of everything after the decimal point. Okay, so keep that in mind, that the computer might actually end up doing integer division on you as opposed to regular mathematical division that has decimal points, depending on how you work with the data. So there's a bunch of other stuff that you can do, but the idea is you have expressions, for example, mathematical expressions, that end up returning some sort of value. Now, why don't we do something a little bit more interesting? Let's say we also add a string to this. A string is really just a series of letters and numbers that is treated as text. So we can say 1239 divided by 193 equals, and now we have this really weird thing, because if you're working with a string, it's expecting this beginning quote and this ending quote, and then you can what's called concatenate, combine strings together, where you say this string and then you have this multiplication, well, division that we had previously. We have this plus sign over here, so it's a little bit odd, but let's run it and see what happens. We compile this and we run this. We get 1293 divided by 193 equals colon, and then we have the space here, and the number that we previously had. If you really want to make this extremely clear, you can also add a parentheses on there and run this, and it's still basically exactly the same as we had previously. So what happens is the computer, again, generally translates the code, executes the code from left to right, top to bottom. But in this case, that's not what happens at all. The computer looks at all of this and it goes, oh, 1239 divided by 193.0, I recognize that. I can do math. And it goes and does the math for that first. And then it goes, okay, now that I have 1239 divided by 193.0, and this is 6.419, then I can concatenate, I can combine that number with this string because the programmer, the user, you, gave this plus sign over here. Okay, well, same thing as what we just did. If we simply give 6.419 right here, it treats it as a number, but it also combines it into a string together to print to the screen. Okay, so that is the very basics of working with expressions. That the idea is whenever you have an expression, whether it's mathematical expression or something beyond mathematical, and in this case we have a string expression that combines a string and a number, we end up with some sort of value before that value is then executed, in this case printed to the screen. All right, now let's add variables into this so that we can work with something a little bit more useful. Values from expressions can be stored inside of variables. What does that mean? A variable has what's called a variable type, and it also has what's called a variable name, and then some kind of value. Now, we're going to talk about just two basic variable types today for this particular episode, because I'm going to get into a lot more variable types next episode. So let's say int number equals 0. And then remember again that this is a statement. We have the semicolon right there. We can do system out print line number. All right, let's see what happens. Then we say 0. The computer looks at what the value is associated with number, and then it prints it. That's what happens. All right, great. So what if we say number equals to 6.419? And then, oh, actually, number is an integer. You cannot do this. You cannot enter in a decimal point into an integer, which is why it was giving you that error. In fact, if we come back here, it says incompatible types, possible lossy conversion from double to int. Again, next episode, I will explain what that means. For now, we just get rid of the decimal point because an integer cannot have decimal points. That's part of the limitations. Of course, part of the question is going to be, why would we care to work with all of these limitations? Why doesn't it just work automatically? We'll explore that next episode too. So for now, we have number equals to 6. Now, if we compile and we print it, wait a minute, what happened? It still prints 0. That's because right now, system out print line number is printing out what the number is exactly at the time this statement is executed. Remember, it executes top to bottom, left to right for the most part. So the first thing it did was int number equals to 0, and then it print the number, whatever the number is at this point in time, and then the number got changed to 6. And if we want to see the change in the number, then we'll have to print it again to see that indeed number is now 6 instead of 0. And there we have it. Okay. We can also, like I said, enter in some sort of an expression inside as a value to be given to a variable. So here, let's say we do 193 times 6. Compile this, run this, and we get 193 times 6 is 1158, which is something that we knew previously. that number, 1158, is put inside of number, and then now we print out number as it is. Okay. Now what happens if we do number equals to 1239 divided by 193, and then we print out system out print line 1239 divided by 193 equals to number. Compile this, run this, and we get 1239 divided by 193 equals to 6. Because remember, again, the computer sees this as what's called integer division. It takes the whole numbers and it gets rid of all of the decimal points to keep just the whole number. And what happens if we try to do the 0.0 like we did before? We get the same error, possible lossy conversion from double to int. It's a, hey, you're trying to work with decimal numbers when number is really just an integer, and that's not okay. It doesn't allow you to do that. Okay, great. So those are numbers working with integers. Let's also work with string variables. Words, any combination of letters, numbers, special characters, etc. can be stored inside of a string variable. Now we have the string variable here, 1239 divided by 193 equals, well, let's put that into a string variable. String message equals with the message that we had, and then we can do system out print line message plus number. So again, the computer is going to look at what number is at this point in time, and then it's going to look at what the message is at this point in time, and it's going to concatenate, take the two strings, take the two combinations of things together, combine it to print one whole string. Oops. Okay, compile, run this, and we get the same message, 1239 divided by 193 equals 6, and we can change the message to over here, 1239 divided by 193.1111 equals blah. Compile this, run this, and the message changes. Now keep in mind that this message, this string, is whatever we want. This is just a string. The computer doesn't actually know that the message is supposed to be related to the number that we're giving to it. As far as the computer is concerned, they are not at all related. That's not how the computer thinks about things. Right. And in fact, we can change this to, let's say 1239 times 139 equals, compile, run, and now it says 1239 times 139 equals 6, which is clearly wrong. And this is actually kind of an example as to how bugs or issues happen in the first place, because the computer doesn't really think the way humans do. It doesn't do these double checking and error checking in the background. It just goes, what you're telling me to do, does it make sense? Can I execute it? Yes, I can. Then fine, I'm going to just execute it as is. All right, so variables, as you can see, can also be used in statements and also can become its own expressions in itself. So now to wrap things up, let's talk about comments. Comments, for the most part, are actually ignored by the computer. And this brings the question, what is the purpose of comments? Now the purpose of comments is really for you yourself to understand what's going on, as well as communicate to other people in terms of what the purpose is of the code that you're writing, so that other people can understand it better, so that other people can edit it. For now, just understand that comments are super useful for maintainability, for understanding your code. There's also such a thing as Javadocs. So Javadocs are a little bit different. Javadocs are things that allows you to add additional data that can automatically be pulled out of your code so that people can get documentation from it. So for example, if you have author, version, since, etc., and various descriptions, a special program can go and take all of these things and put it into its own documentation so that it's a little bit easier instead of having to create your own documentation separately. So for example here, write a description of class hello world here. We just say a simple example of main method, expressions, and variables. And then author, I can put my name here. And version can be anything that you want. It can be any version number that you care to give to it. It can be a date. You can say that this is version 1009. It doesn't care. This is entirely just a comment just for your own purposes to keep track of it. We can also add inline comments that says message to show to the user. And here we can just say number, just a generic integer for the purposes of demonstration. That's it. Again, we can compile this and we can run this, and the comments for all intents and purposes does nothing in terms of running the code. That's really it. The comments are really just for you to keep in mind what needs to happen. Now, inline comments begin with 2 forward slashes, and this actually comments out everything after it in the same line. So if, for example, you have number equals 193 times 6, and you enter in a comment here, just a generic number, you'll see that it comments out everything after this 2 forward slashes. And that means that the computer now thinks that, hey, I'm expecting some sort of semicolon over here to end the statement, but I'm not seeing it, so it goes to the next thing thinking that it's still the same statement, and it's saying semicolon expected right here, which is clearly wrong. Now, if you add a semicolon over here, well, it says not a statement, because this is just a variable name. It doesn't actually do anything. It's like, what are you trying to do? So be careful where you put single line comment, because it will comment out everything for the remainder of that particular line. Now, in terms of commenting though, you can have what's called multi-line comments. And even though it's called a multi-line comment, similar to what we have over here, you can also have it in a single line. So let's say we would do here number, quote unquote multi-line comment, just a standard number integer variable thing. And then we close the statement. Now we can actually have a statement. We can have a comment that is within a statement, that is inside a statement, and have the remainder of the statement inside of it, which is kind of interesting. Now, in practice, hardly anybody ever does anything like this, but if you really want to, you can absolutely totally do this. The computer doesn't really care. Does this make sense? Is this pleasant to look at? I don't know. It's your code. You decide. All right. So same good habits as with block statements. Once you open a multi-line comment, definitely close it before proceeding to add the comments. And that's really it for today. Pretty short episode. And some of the things that I always ask you is, were there anything from this episode that was obvious to you? Were there anything that you learned, anything new that you learned? And if you like this episode, please subscribe for more content. Next time, we will be going a lot more in depth in terms of variables, which is a very crucial, a very key concept to understand for programming. And if you learned something, especially if you're one of my students, tell me if you learned something or if there are other things that are not obvious to you. But even if you're not my student, tell me in the comments, and I'll see you next time. Thank you.